Imagine a classroom with two teachers trying to teach different subjects at the same time. One teacher is explaining geometry, while the other is talking about planets. The children are trying to listen, but with all the different information flying around, they get confused. They hear messages meant for others, and it's hard to focus on what's important for them. This is a bit like a single broadcast domain in a computer network. All the traffic is mixed together, leading to confusion and inefficiency. Now, what if we put a wall in the middle of the classroom? Each teacher now has their own dedicated space, and the children can clearly hear and understand their own teacher. They're no longer distracted by the other class. This is the basic idea behind virtual local area networks, or VLANs. In a computer network, devices often connect to a central device called a switch. Without any special configuration, all devices connected to that switch are part of one large broadcast domain. This means that if one device sends out a broadcast message, a message intended for everyone, every other device on that switch receives it, whether they need it or not. Imagine all these unwanted messages constantly flowing through the network, like the confused chatter in our first classroom. This can overwhelm devices and congest the network links, slowing everything down. VLANs solve this problem by allowing us to logically divide a single physical switch into multiple virtual switches. It's like building those walls inside our classroom. We can group users and devices based on the function. For example, an admin VLAN, a user VLAN, and a guest Wi-Fi VLAN. Now, broadcast messages sent within one VLAN only stay within that VLAN. The devices in the admin VLAN won't receive broadcast messages from the guest Wi-Fi VLAN. This significantly reduces network congestion and improves security. While devices within the same VLAN can communicate freely, what if devices in different VLANs need to talk to each other? For instance, what if an administrator, in the admin VLAN, needs to access a user's computer, in the user VLAN? VLANs, by themselves, isolate traffic. To enable communication between different VLANs, we introduce a Layer 3 device, typically a router. The router performs what's called inter-VLAN routing, allowing traffic to flow between these separate logical networks. The beauty of using a router for inter-VLAN communication is not just about connectivity, it's also about control. The router can enforce policies on the traffic passing between VLANs. For example, we can define a policy, no user to admin access. This means that devices in the user VLAN cannot initiate a connection to devices in the admin VLAN. This is crucial for security. However, we could also have a policy that states, admin can access user, allowing administrators to connect to user devices for support or management. By combining VLANs with routers and their policy enforcement capabilities, we create highly organized, efficient, and secure networks, ensuring that information only goes where it's intended, just like a well-managed school with clearly defined classrooms and rules.